What's up, everyone? It's Algebra 2 time with Miss Wesley, and I could not be more excited to be here. Today, we get to put to good use all of the skills we've been working on with rational expressions and use them to solve rational equations. So get excited, get ready, get out your rational packet, and join me on page 30 to take some notes. While you're pulling out the packet, what could be better than a little joke or two to entertain you? So the first joke is, would you like me to tell you the rumor about butter? Well, I wish I could, but I don't want to spread it. And the second joke is, how does the moon cut his hair? Eclipse it. So we're going to actually skip to the middle of page 30 in a second, where it says steps for solving a rational equation. The beauty of these videos, I want to remind you, is that sure, I may get excited, I may talk fast, I may write fast, I may zip through, but you can slow me down, you can pause me, you can try a problem on your own and check back with the video and check your work. You can even rewind to watch a part again. So a rational equation, right? You hear that word a lot in mathematics. Rational expressions, rational numbers, rational equations. A rational equation contains at least one rational expression, right? The thing that we've been dealing with all over this unit. What is a rational expression? I see a bunch of them here in this example. Expressions that specifically have variable denominators. I see x's in all three of these denominators on both sides of the equal sign. Versus this one, there's no special set of steps here, right? You're just solving this. You've got a couple fractions in your equation, but nothing with variables in the denominator. Those set of steps would be different. So what I want to introduce you to with number one here is my favorite way to solve rational equations, and you can kind of follow along with the steps as we try this one. Taking a look at number one, and I'm looking through those denominators, and I'm feeling like it's not a coincidence that they gave us denominators like these. I feel like this, right, is giving vibes of these other two denominators. Like I can get these parts out of this one. So you'll see in step one up above, it says, can you factor, right? Factor all denominators to see if maybe, just perhaps, this side will have something in common with that side. So I notice the difference of squares that's begging us to change it into an x plus 3, x minus 3, and that makes this denominator have both parts I see and the denominators on the other side. That's going to be convenient for us. A goal, as we go through this entire page solving these four equations, is going to be to get the denominators to clear. If there's a way to rewrite these equations without denominators, we are in such a better spot. The equation will be a lot quicker to solve. One thing to keep in mind the entire time, though, is the domains of these four equations is not all real numbers. So we're just going to have to watch out for extraneous solutions. You'll see that in the checking step 4. We don't want answers like in this first one. I don't want to get an answer like 3 or negative 3. Anything that when plugged back in would give you division by 0. Okay, so the big move is going to be step 2. It says once you have this thing factored and all the parts are kind of like split up into their simplest form, we are going to clear the denominators by multiplying everything by the least common denominator of all the denominators you see. So what I'm going to do is I notice we've got an x minus 3 and we've got an x plus 3. I'm going to do something that we are allowed to do. You're allowed to take any equation you like and multiply it through by the same value or expression, as long as you don't forget any term. So really, it seems like what I'm about to do is kind of funny, because a lot of what we did with adding and subtracting rational expressions was putting a common term in the numerator and denominator of each fraction. What we're doing here is we're giving this expression in red to the numerators, but of all three sides, which we are allowed to do. It keeps the expression balanced, keeps the equation balanced. So when I multiply it by this first expression, I notice the x minus 3 and the x minus 3 are going to divide to 1. Those are going to cancel out. All you'll have left is this x plus 3. I'll still have that. And I still have this x left over, and that's what I write. I'm going to write the x and the x plus 3. So I'm already feeling good about this because I have no denominator in that first term anymore. What's going to happen when this goes through to the next part? So I'm going to take that same expression in red, multiply it through by the second fraction. Do you notice something canceling? If we do our job right, this x plus 3 is going to cancel with that x plus 3. And our job is to write what's left over. So what do we have left over? We still have the x, and we still have the x minus 3 that aren't going to cancel. So x minus 3. Love it. No denominator for that. My favorite part has to be the next part. This 2 is sitting pretty over both parts of this common denominator. The entire x plus 3, x minus 3 is going to cancel. It's going to divide to 1 with that x plus 3, x minus 3 that needs to go to the other side. Anything left over to write there? Because the way I'm looking at it, it's just the number 2 on the other side. So this will take, a little bit to get into the rhythm with some more practice, but we're in such a better situation now because this is no longer a rational equation to solve. This reminds me of a few units ago when we were just solving quadratic equations. This would be a good time to pause the video, solve the quadratic equation on your own, and then maybe start up again to check your answer. I'm going to walk through the steps though. We've got to distribute, so x squared plus 3x, and then what? X squared minus 3x. Like that. We'll combine like terms, see what this is looking like. We've got these things adding to 0 and 2x squared equaling the number 2. The 2's, right, we can divide both sides by 2 and get x squared equals 1. And then square root both sides, remembering what? Answer's not just 1, the square root of 1, right? The positive or the negative when we square root both sides of the equation. I mentioned a really important step about checking your answers. Always a good idea to plug back into the original equation and see if it gives you a true statement, to leave your answer there, feel comfortable about it. For us, I'm just going to do the shorthand version of the check. I'm going to inspect any denominators and just make sure I'm not leaving an answer on my paper that's extraneous and that causes you to divide by 0 at any step. And 1 and -1 check out. You got your 2 solutions. Okay, can we try this a couple more times? Let's look at number 2. For number 2, now I'm kind of trained, my eye is drawn to that first denominator. I feel like maybe we can get so lucky that you'll see the factoring gives you the parts that you have on the other side. So if we factor this quadratic, because this looks like the only denominator that's going to factor, we get so lucky that it should come out to be the other 2 parts of those denominators. Doesn't always happen this way, and really if that doesn't happen, we still have a job to do. We've still got to multiply both sides through by every factor that we see in the denominator. So this is probably the biggest step of the problem. We're going to put the x plus 2 and the x plus 1, which are the only 2 parts I see in any denominator of this equation, and we're going to bring them into all 3 numerators. All numerators that you see on both sides of the equation. Like I said, we'll know that we did our job right if denominators cancel when we do so. So I think it works out very nicely in the first fraction. That x plus 2, x plus 1 is going to divide to 1 with this 1 in red that I see sitting down in the bottom. All I should have left over is this x minus 1 in the first fraction that was sitting up top. Okay, second part. Take this slowly, bring it to the second one. What cancels? The x plus 2's are going to divide to 1, and then we write what we have left over. So we have plus, this 2x is still there. And what else? Oh, the x plus 1 is also still there. And the other side, let's see what goes away. So x plus 1's are going to vanish. They'll divide to 1. And I'll still have on the other side the equal sign, a linear factor times another linear factor. So x minus 1 times x plus 2. Okay, great time to pause and try to solve on your own. I'm going to this is just a quadratic equation, nothing big, nothing groundbreaking. So I'm going to try to kind of zip through the steps to getting a solution, and we'll check that as well. So what do we have? We've got x plus x minus 1 plus 2x squared plus 2x. We'll distribute, and then same thing on the other side. Go ahead, take your time with this, and you'll distribute carefully, get something like that. We want to slide everything to one side of the equal sign, and maybe our most convenient move would be to move everything to the left, keep a positive leading coefficient. So 2x squared minus x squared. Linear term, you have 3x minus x, so plus 2x. And then we're going to add 2 to both sides to get a plus 1 as our constant term. This thing, check me on this thing should factor into the same linear expression twice, x plus 1 times itself. Feeling pretty good about this answer, but maybe I should be feeling a little bit more uncomfortable. If I plug this back into the original equation, yikes, it's okay plugged into this part of the denominator, but not here. It'll give you 2 instances of dividing by 0, which makes this answer extraneous, outside of the domain. So a sad story, the only answer that algebraically works is an answer that is not allowed, and we'll just say there is no real solution to that one. Okay, I'm taking a look at 3 and 4, kind of getting into the groove now, and 3 just almost looks too good to be true. I know I'm supposed to multiply every expression, every rational expression by the common denominator, but there really is the same denominator on both sides. In a way, they both just get crossed off. You don't even really have to show this step where you're distributing this into both parts, because that really does. It cancels the x plus 2's here, and it cancels the x plus 2's there. So really, it's these numerators that need to be set equal. They're setting over the exact same thing. So again, I might like this one the best. Go ahead, take your time, solve this quadratic equation. You can even pause while you solve it, and then check your solution. Just make sure it doesn't give you division by 0. So in doing so, you want everything on one side. Maybe we'll go for the right side this time and do x squared, subtract x, so plus x, and then I think minus 2 if you're adding 1 to both sides. This should give you 2 potential solutions. Sometimes they both work, but I guess not in this case. I think -2, not such a good answer. In those original denominators, it would make them both 0. So I got to get that one out as extraneous, and we'll keep the answer 1. Algebraically, it seems like we got it in a pretty good way. Okay, number 4. Looking through, nothing really to factor for this one. I just see, I noticed those x plus 4's happen twice. So if we want to do ourselves a favor and not write this as 3 different expressions, there's a shortcut for number 4. We can leave, I'll star this one, we can leave this expression on the left side, right? Because this is the one that's over x plus 1. On the right side, why don't we move the 2 fractions that have x plus 4's as the denominators to the same side of the equation? So I'm going to subtract the 3 over x plus 4 to the right-hand side. The reason I'm doing that is it's just going to make my life a tiny bit easier to combine like terms. I see now that I have on the right side a built-in common denominator. So it'd be easy to add those 2 up. You've got the left side, that's x over x plus 1. You've got the right side, it's x plus 3 minus 3 all over x plus 4. Loving the look of that, right? So now we've got one fraction equaling one fraction, kind of like we did the last time. Well, really for this, we can multiply both sides by what's in the denominator, or we can multiply both sides by their respective denominators when we have a fraction equals a fraction. So really, I'll get, and some people call this cross multiplying, I'll get x times x plus 4 equals the other side, this x times this x plus 1, right? Even if we did this the same way we solved the others, it should come out this way. So this works because you have one fraction equals one fraction. It's the first time we were able to do this on this page. If I simplify, I'm curious, x squared plus 4x, and you get distributing x squared plus x. I want to maybe subtract x squared from both sides. So we're getting 4x equals x. And then maybe I need that 4x and that x to be on the same side of the equation. I want to combine the like terms. Let me subtract x from both sides. So I subtract 1x, and I get 3x equals 0. Well, divide both sides by 3. The only thing I can think of, the only x value that would make that green equation true would just be 0 itself. If I look back up into the original equation, 0 looks fine. It should check out, and you can try plugging it in just to make sure we got the right answer. Doesn't make any denominator 0. I'm going to leave that as a checked solution. If you could turn 2 pages ahead to the homework problems, the last thing I wanted to do was just give you the setup for a couple of these word problems, and we can talk more about this in class. But on the middle of page 32 here, I feel like if we do setup for number 2, it might help you with number 3 as well. And sometimes they remind me of SAT questions. They can get a little bit tricky. But it says one pump can fill a tank with oil in 4 hours, and a second pump can fill the same tank in 3 hours. If we think of this with rates, we can write our own rational expressions with some variables in here. So pump 1 can fill 1 tank in 4 hours. You could say its rate is filling 1 tank in 4 hours. Pump 2, what would that look like? What fraction? It can fill 1 tank in 3 hours. Together, right, we don't know how many tanks or how many hours it will take to fill 1 tank, but together, one way to do this is to say they'll fill 1 tank in X amount of hours, right? If we add it up, right, pump 1's rate, 1 tank in 4 hours, plus pump 2's rate, 1 tank in 3 hours, it should equal our together rate with both pumps working together. So that should equal 1 over X. This is, again, not the only way to solve this, but one method to set this up. I'm going to let you take it from there, solving this rational equation, getting the denominators to wipe out, and solving for X. Hope you have a nice day, and I'll talk to you soon.